Yes, so as I said, we will work on the exponential functions and logarithmic functions. Well, what is the exponential? Where does this exponential function start? When you fix a base, here by base mean any number, any real number, which is bigger than zero. We don't have base for negative numbers and not equal to one. There's a reason that we don't like to put base to be one, though the assignment when you send x to 1 to the power x is well defined, but we exclude b being equal to 1. This guy, this function is called exponential function. Before we go to the details, there is one remark that you have to make sure to see it clear, very clear at this point, and that is exponential function versus power function. Power function is when you send x to the power some number. So we have something to the power another thing, but the base is the variable. In the exponential function, the base is constant. It's fixed number. The power, the exponent is the number, the variable, the input. In other words, 2 to the power x is exponential function, while x to the power 2, f of x equal to power 2, is a power function. So you have to make sure that you understand those properties. Well, the first thing before we even look at these guys as functions is the properties or exponential rules. So exponential rules. The simple one saying that, okay, you have same base, you want to multiply the two expression. So in that case, you get better to write all in B. I already put the base as B. So you can write one base, then add them. For the ratio or division, that will work a little bit different. You will get b to the power x minus y. Then you have, when you have same power, different base, you can write it as you multiply bases and then put one power up there. If you do the same power and divide, then you basically divide the base and put one of the powers. There's also one important notation that when you're looking for nth power of something or nth root of something, this is also an exponential expression, which is b to the power 1 over n. One more thing is that the exponential of exponential, this is done this way. Okay. Well, I will do just one or two of these guys just to show you how this works. For example, I'll first start working with the denominator. Denominator, this is a to the power x, b to the power 4 to the power half, and a to the power 2x plus 3, b to the power minus 6 plus 2. Then I'll use this property here, and I write this as x, a to the power x times half. This is a to the power x over 2, b to the power 4 over 2 is 2, a to the power 2x plus 3, b to the power minus x plus 2. And then I can separate the denominator, and I can write it as this guy. And then using the first or second rule, we get a to the power x over 2 minus, 2x minus x over 2 is 3x over 2 plus 3. And this is b to the power minus x plus 2 minus 2. This is b to the power minus 6. And that gives you the final answer. Let me maybe do this one very fast. This is a to the power 5. The exponent, the root goes as 1/6 there, b to the power 4 to the power 3, and this goes as a to the power 4, 5/6, b to the power 4, the whole thing to the power 3. Then expand the power there, this is a to the power 5/6 to the power 3, b to the power 4 to the power 3. And that gives me a to the power 5/6 times 3 is 5/2, and b to the power 12. And that's how you get those kind of. I will leave this one for you as an example and try to move to the other words. Any questions, any comments here? Well, let's just look at exponential functions. We want to know a little bit about these ones. The first thing is what is domain of exponential function? I'll write exp in general. Well, you see, I have b to the power x. B is positive. X can be any real number. So this means that I can plug in any number as input for the exponential function. As for the range, if you have a positive number and you try to find different exponents of that guy, the result is going to be always positive. And I can get any number I like there, and actually the range is going to be all positive numbers. As for graphs, this depends on the base b. If b is positive, or sorry, bigger than 1, well, obviously positive, in that case, the function b to the power x will be like that, and it will pass through the point 1. However, if b is the other part, which is bigger than 0, always we take base to be bigger than 0, but less than 1, then b to the power x is given by this. There are a few things that now, just by looking at the graph, you can check. This one is that, the range, you see that it takes everything which is bigger than 0. So that is the range. That's one way to check the range. The other thing is that the exponential function, no matter what b you take, b bigger than 1 or between 0 and 1, it's going to be 1 to 1. In other words, any horizontal line intercept with the graph of exponential function only once. And well, that's a good thing, because we just learned last session that if something is 1 to 1, we have to be able to find its inverse. The inverse of exponential function is the second part of our tutorial today's logarithmic functions. And there is one special case when the base is e, then we call this function x sends to e to the power x as the natural function. What is e? There are very nice things about this e, but here what I need you to know, e is a real irrational function. Irrational numbers, sorry. It means that when you write its digits, it will never stop. It will continue. But numerically, what I want you to know is that e is about 2.7. And as a result of that, you see that e to the power x is going to have this graph, because e is bigger than 1. So the graph of that guy will be that the natural exponential function will be like that. Any questions, any comments here? Okay, let's just do a very quick one. Sketch the graph of this function. You see, I can start with function e to the power x. I won't do details of this, but what I need to know at this point is that this is the graph of the natural exponential function, and it passes through 1. Then I can do one operation. Here I choose to switch x to x minus 1. Then I get a function, I call it f2, replace x by x minus 1. So it will be e to the power x minus 1. And then the next operation, I turn x to 2x. And that will give me the third function, which is e to the power 2x minus 1. I'm just changing x, yes? Here there's only one x, I change it to 2x. And then there is a next transformation, which sends the function to 3 times of that function. And that will give me the fourth function, which is 3e to the power 2x minus 1. And the last step is that I just need to send the whole function, the function minus 2. That will give us my the function that we are interested in graphing. It's sketching its graph. Okay. As I said, I won't go to details, but I will write down what are each one of these transformation going to do. So x goes to x minus 1. This is horizontal. Shift to the right 1 unit. That's what that transformation does. Then I multiply x by 2x. This is horizontal. This is horizontal shrink by factor of 2. It means that the y-axis stays the same, but everything else you multiply it by half. It will get closer. So we are shrinking horizontally the function. If 3, you multiply the whole function by 3, that means that we are vertically stretching by a factor of 3. And well, the last one is the vertical shift 2 units downward. Okay. Let me see, I have, okay, no, those questions are not for me. Okay, yes, so I will leave the rest for you to just do the transformation, and then finally, after 1, 2, 3, 4 operations or transformation, you get the sketch of the given function. Any questions, any comments here? Okay, let's do the last example. You see, functions, when you look at the functions, there are, well, tons of information and determining functions just by looking at graph or some pieces of information about the function is not an easy act to do, easy job to accomplish. However, if you know the form of the function, in this case, it is given here like this. The function is of this form. What is C? What is A? That's the question. That's what the question is asking. What are the values of C and A in this function if we have these two properties? The graph of function crosses y-axis at -2 and passes through the point 1 and negative. So let me just write down the information. So the graph crosses y-axis at -2. What does this mean? This means that you see points on the y-axis, when you try to find the coordinate, the first coordinate is 0. The second coordinate is whatever the point at which the value of y when you wherever you cross that axis. So it means that this guy 0, -2 is on the graph. But points on the graph means that when you plug in this one as the input, the output will be the second coordinate. That's the best translation of what is written here. The graph of this function crosses y-axis at -2. The other thing is given here, just while 1 and -5 is on the graph of this function, yes? So that will imply that if you plug in this as input, the second component will be the output or the value of the function. So these are the given information, but I know some more information here. So the function has this property or this format. It means that I can calculate f at 0. So let me just denote this guy by star. I can calculate f at 0 by looking at the format of this function. This will be c e to the power a times 0. So from this, I can see that, oh, f at 0 is given using graph. F at 0 is given by the form of the function. That means that -2, which is value of f at 0, must be equal to c e to the power 0. But e to the power 0 is 1. So c is -2. Just by knowing where the graph of this function crosses y-axis, we were able to fix one of these two constants for this function. Similar work can be done here, but now I also have more information. So not only I will use the 4, but also I will use the fact that c is -2. So f at 1 is -2. Instead of c, I plugged in -2, e to the power a times 1. And again, these are both values of or outputs of function for input 1. That means that -5 must be -2 e to the power a. Well, I want to find what is a. Yes, this is the question we have. So I have to solve. So I write this. I divide -2 to the other side. I get -5 over 2. And now I want to find the value of a. Here is where the inverse of exponential function comes in. We know that the exponential function, the inverse of that is logarithmic function, the base e, and logarithmic function base e is denoted by, this is the natural log function, which we call it ln. So to get rid of e, we do apply ln to both sides, and that way a ln of e to the power a, it's the inverse. It cancels or basically goes backward. A function exponential sends a to e to the power a. Exponential logarithmic function sends e to the power a to a, and this is equal to ln of 5 over 2. This is the value. So in other words, our function is of this form, -2 e to the power ln of 5/2 times x. That is the answer we have here. We will go a little bit more on log functions right after this, but is there any questions, any comments before I move to the next slide or next page? Okay, I take that as we understand all these ones and we are okay moving to the next set of problems. So logarithmic function, log functions. This is exactly, as I said, the inverse of exponential function. So exponential function sends x to b to the power x. Now we want to find the inverse of exponential function. Why we are allowed to ask about the exponential? Because the inverse of exponential, because exponential function is 1-to-1. That's why if this guy is f, then f inverse will be something that we denoted by this guy, log of x base b. In other words, the precise definition is this: y is equal to b to the power x if and only if log of y base b is x. In other words, when someone is asking you what is log of y in base b, you're trying to find what is the number. When you put in the exponent of b, you get y. That is exactly the value of log. Let me see, I see. Fabia is asking, do we keep that as exact value? Yes. You see, ln of 5/2 is a good number for me. I don't, well, I can approximately try to understand it, but it's good number as 1, as 2, as 10. And that's why I don't need any calculator for this course. Ln of 5/2 is a good number. In quizzes, in the exam, in the test, you just leave it like that. That's a good number. Okay, what else we know about the log function? Well, we know that domain of any function is range of its inverse, yes, but the inverse of log is exponential function, and range of exponential function we know is 0 to plus infinity. Okay, Alexandra, would be nice when you have question, you turn on your mic, but I see the question now. So what was the B? So this is the definition of log. Someone is asking you what is log of y base b. It means that find the number when you put in the exponent of b, you get that number y. It's completely the other way around of the exponential function. If someone says what is exponential of x, you say that, okay, with base b. So you have b, you put it in the exponent, b to the power x is the exponent. Now, log is the other way around. Someone gives you a number, you're trying to find what is the number. If I put in the exponent of b, I will get this number. That's the log of this function. Okay. So one important and very, very crucial fact for us: log has this domain 0 to plus, and log of only positive numbers are allowed. How about the range? Well, we can find it in two ways, but I'll write it here. Range of log is the domain of exponential, but exponential function can get any number we like, so that is R. How about the graph of function? Well, graph of function, you know that we get it by finding the reflection of the exponential function. So let me just draw this guy as exponential function. So this is b to the power x. I'm assuming here b is bigger than 1. Then the ln function or log function base b will be reflection of this guy with respect to this y equal to x line. So that will give me something like this. Try to be precise. So it passes at 1. This was 1. This is log of x base b. And as it goes down, as x goes closer to 0, the log gets to very big negative, very negative numbers. What about the other base when b is bigger than 1, less than 1 and bigger than 0? Well, we know that the graph of these guys is of this form. So b is between 0 and 1. So this is b to the power x. Y equal to x is going like that. Sorry about that. And then the reflection will be something like this. This is log of x base b. Again, b is between 0. And just by looking that, also you can find the range of these functions. Yes, Willow, please go ahead.
What would be an example where you would see y equals x? Like I'm not like I get that it's reflected over that line, but I don't quite understand when you say like y equals x. Or where
this is the equation for this line.
Yeah.
You see, what happens is that when you have a function, the first point, every point has these two components, yes? A point, an input, and the value of that as output. Okay?
Yes.
But then when you go to F inverse, you basically turn these guys around. You just write it, the first component as y, the second component as a. And this flipping the coordinates of a point means you find the reflection with respect to this y equal to x line.
Oh, okay. So you're just essentially, like you said, flipping the coordinates.
The coordinates. And flipping coordinates exactly is what's happening for the coordinates of the graph of inverse of a function.
Yes. Okay.
That's why we always find the graph of inverse function by reflecting the graph of the original function with respect to y equal to x line.
Okay, makes sense. Thank you.
You are welcome. Out of all these properties, the log properties, which I won't go over, and I expect you to do your homework there, you try to make sure that you understand log properties. Other than log properties, which is how does log work with the product, with exponent, with different things, there are two properties which are very important. And this is basically the definition of log being inverse of exponential function. It says that if you go first by exponential function, so you take x, put it as exponent to b, and then find log of that guy, this will be x. In other words, log and exponent cancel each other. That's other way of saying these are inverse. So if you start with this machine going from x to b to the power x, and then come back by its inverse, you go back to the original input that you came from. Also, the same thing works for the, if you go first, find log of x base b, and then exponent, this will be x. So you sometimes see writing these ones as inverse function properties, but you have to know these ones, the function properties. These are going to do a lot of good things for us. Well, in particular, remember that the natural exponential function, the natural log function is denoted by ln. Yes. So ln has the same property, but when the base is specifically e. Ln is basically just, this guy is so important. We made his name or her name very special. We call her a little bit differently, ln x, and that's basically having the same property. Okay. So I will leave these first examples for you, because these are just checking the properties of log. I would rather to just move to the function related problems for the log and try to do those. Do it yourself. Make sure you understand all of those ones, okay? Finding log, the domain of a log function. Here is ln. Ln is log base e. This is just a special way of calling log base e. We know that domain of a function. Remember that for the domains, we had two restrictions. One, the denominator cannot be zero. Under the even roots must be non-negative. Now, after introducing inverse functions, inverse trig function, inverse exponential function, we have new restrictions. And as you saw up above, that we can only find ln or log of only positive numbers. So the domain of this guy is all the real numbers, but the ones which makes the input for ln bigger than 0. I have to solve x squared where x squared minus 3x plus 2 is positive. Can anyone tell me how to solve that inequality? I need an answer there.
You would solve it like you would solve roots or x's.
You would solve it. Sorry, who was speaking? I couldn't catch that.
It was Fabiha.
Fabiha, yes, yes. So you're saying that you solve it as, you solve it for what?
Solve like you would for x's, like in a quadratic equation.
Oh, I see. So you're saying that this will be something like this, yes? You mean like that?
Yeah.
You see, this is equality. There is a relationship here, but in general, so let me just tell you one thing to keep in mind. When you're trying to solve an equality like this, or in any form that you like, when you have bigger than equal, the best way to solve those ones is sine table. In other words, I want to find out where this expression is positive and where it is negative, and then I only keep the positive part. That's why solving that is equivalent of finding sine table. But sine table starts always with setting it equal to 0. So sine means either positive or negative. There is one thing in this middle, which is 0. So let's just first find the 0. That's why you go and first find the roots of this. In this case, this is an easy quadratic. You can use either quadratic formula, or like this, you do get rid of sorry, you do factor, And then either this one is 0, which means x is equal to 2, or x minus 2 is x equal to 1, sorry. And x minus 2 is equal to 0, or equivalently x is equal to 2. So now I know that for x at 1 and 2, my expression, which is x squared minus 3x plus 2, at these guys, this is 0. And then, well, go ahead and use the techniques you know for this sign table. I would suggest you plug in sample points and see what kind of signs they have. This will be of this. We are only interested in values for which the expression is positive. So this will be from negative infinity to 1, from 2 to plus infinity. Can anyone tell me, should I include 1 and 2? Or in other words, should I put round bracket for 1 and 2, or square bracket?
Round brackets,
And why is that?
because 1 and 2 are 0, so they're not included.
Exactly. So the inequality here just says that find the values which are strictly bigger than 0, not 0. So that means that I'm not interested in 0 wherever makes this expression 0, and that's why I should exclude those. So the domain we found that these are all x's in R for which x is less than 1 or x is bigger than 2, or equivalently, I can write it as the interval notation with round brackets in this case. So you have to be able to do all those cases. Any questions, any comments before I move to the other one? I think I have I have 3 questions. I should go a little bit faster here. See, finding the inverse of a function, you remember I take an output and try to see what is the input which gives you that output. Yes. So in other words, you start with this guy and try to solve it for x. So, well, we go just as the simple rational functions we did. So 1 multiply both sides by 2 minus e to the power x. Expanded. Then bring in all the expressions in x one side and let everything else to go to the other side. So minus 3 to the power x minus e to the power x equals to 1 minus 2y. Then, okay, I can factor out e to the power x, the only expression in these guys, which is always a factor of the terms. And now I can solve this. I can divide that to the other side. Very nice. Well, to get this output, my input x should have this property. E to the power x must be equal to that value. But to get rid of e to the power x, I can take ln of both sides. The left-hand side will be just x equals to ln of 1 minus 2y over negative 3 minus 2y. So this output is obtained by this input. We have found the F inverse. F inverse of any output here, y, is going to be obtained by ln of 1 minus 2 that output, negative 3 minus output. Well, that box, I can replace it by any expression. That's just placeholder. I can put x, and that's what is the inverse of this guy. Very good question for this guy will be that I will leave it for you, that find the range. This is a very nice question of this function. We already found the F inverse. If you find the domain of that, that is the range of the original function F. Any questions, any comments here? Adam, yes, please.
I don't know. Hello, Professor. I just had a question. Could it be possible in the second line where it's 2y minus yex equal 3ex plus 1?
Yes.
Could it be possible to do 3ex plus yex equal 2y minus 1 instead? So to deal less with the negatives?
Oh, you take it to the other side.
Yeah.
Yeah, you can. Well, at the end, yes, you can do either side. And when you divide it, then this result will be then in that case 2y minus 1, 3 plus 1.
Yeah, that's what I got. Okay.
Yes, that's the same thing. Expression. You see, I'm multiplying both numerator and denominator by negative sign. So those are basically the same thing. Yes. Any other questions? Any other comments? Let me go a little bit faster here. Well, one of the properties that we discussed can help us to write any exponential function or any log function in terms of natural exponential natural log function. Basically, here what I am trying to say is that I can write this guy as e to the power something times x. And this is always true. You can do that. Any basis for exponential one, you can turn it to basis for the natural. Okay. Well, the way we do it, this is the key point. Remember that ln of e to the power ln of anything is that thing itself. So in particular, if it is 3 here, this will be 3. This is the fact that I was saying that ln and log are basically the same, guys. Ln and exponential, the natural exponential, are inverse of each other. So that means that I can replace 3 by e to the power ln 3 and then to the power 2x. Exponent of exponent is e to the power 2 ln 3 times x. And well, I can use the properties and write it as ln of 9 times x. And with the same kind of work, you will notice that I can change the base for log always. This is one of the properties of log, that log of anything at base b can be written as ln of x divided by ln of b. This also can be easily proved, but I will just go ahead and use this one and write it as ln of x divided by ln of 4, and this is 1 over ln 4 ln of x. I'm just trying to do a little bit more here. This can go up there. So this is ln of x to the power 1 over ln, or in other words, ln of ln 4 root of x. And you will see this is very, very useful when we go to the differentiation. You have to be able to write any exponential function as in terms of the natural exponential function, and any log function in terms of the natural exponential function. I will leave this one for you to do it later. I know that the time is up, but I would say that it's worth to go over time and make sure that we do complete this example. This is very interesting example, and you will see kind of similar idea in one of the quiz questions, actually. Well, this is a bit more difficult than what you will find in the quizzes, but the idea is there. Let me just take another 2-3 minutes of your time and finish this one before we go. Well, the question is solve this one. And the general idea is that, okay, you try to make all these exponential terms in the same base and try to solve it, okay? In this case, I see that 4, I can write it as 2 to the power 2x. And also I can write this one as 2 to the power x, 2 to the power 3 plus 15 equals 0. But this means that I have 2 to the power 2x minus 2 to the power 3 is 8 times 2 to the power x plus 15 equals to 0. No clear thing so far, but if I do one more thing, you see 2 to the power x is here. I want to have other expressions, other exponential expressions also in terms of 2 to the power x. So I'll write it as this, 2 to the power x squared minus 8 2 to the power x plus 15 equals 0. I am trying to solve this equation for x, but if for a second I give up finding x itself, instead try to find just 2 to the power x. I can see that this, in terms of 2 to the power x, is just a quadratic formula, quadratic equation. You see, when there was 2 to the power x there, it was a strange, funny thing. But now if I take 2 to the power x as my new variable, this is just a quadratic. I know how to solve quadratic. I have quadratic formula. I can actually, in this case, factor out this quadratic easily by putting box minus 3, box minus 5, and then setting it equal to 0. So either box minus 3 is equal to 0, that means that box must be equal to 0, or box must be equal to 5. Remember what was box? Box was 2 to the power x. So what I found is that 2 to the power x must be equal to 3, or 2 to the power x must be equal to 5. You know what is 2 to the power x. You want to find what is x itself. You just take log base 2 of both sides. This will give you x is equal to log of 3 base 2. The similar computations will give you x must be log of pi base 2. So there are 2 values of x which will solve this equation, and that's either log of 3 base 2 or log of pi base 2. This was all. Sorry that I went over time. I hope that it was a good review part. I will stop here, stop recording, and if you have questions, you can stay and ask the questions.